Welcome to our next video about Cube software. We proceed here where we stopped the last time. We downloaded all 4 components on our on our hard drive, and here I demonstrate you how one installs them, and we discuss some of the configure command line options and which functionality do they enable, and whether one needs as a user them or rather as a developer. So here we start with Java reader first, because it is simplest component. Then we go to C writer library, then to the general purpose C++ library, and then we finish this video with the installation of CubeGUI. So as a first step, we decompress Java tarball. We go inside of the directory. I prefer to make all builds into the so-called build directory. I usually call it vpath. So before we actually build, we should inspect configure command line options which it offers. So in this case there are not many. Here I should mention that the build system of Cube is based on AutoTools, and therefore one gets a lot of command line options which are provided automatically by the AutoTools and are in most cases, or they are very specific for specific systems, for specific configurations. In 99% cases, as a normal user, one wouldn't need to modify them. One can just take a default value. So in this case, these are basically all of such options. So therefore, there is not much what we can configure in this case. So therefore, we proceed. We specify prefix where our installation goes. In this case, I install it in one directory all together, all 4 components together. That would be, let's say, soft, cube, and the version, which is 4.7. So it's doing a series of checks. In our case, the most important check is this one. The configure script is looking which compiler it's available, whether there is a Java system and jar tool are available, and it is looking for the parsers for the metadata of the cube file, which can be xers or xers impl jar. So the last one is found. Therefore, configure step is successful, and one can proceed with the make and make install. In the end, there is a summary step where we display the key points of this installation. So jCubeR config tool is installed in a build. One can get the help of it. Examples for the from this package are installed in share doc jCubeR example, and so we can do make. It does makes the step, it builds and creates a jar file which one can use then as a library in some project, and actually make install step. Oops. So it is now installed. We can take a look. Home, test user, soft cube 4.7, and here we have a bin directory and share directory. In bin directory we have then jCubeConfig tool, which we generate or provide. Here one can see that it provides it has 4 command line options: version, class path. So if one is developing some project and would like to use this library to read the cube files, so here one can learn how one extends the class path. In order to build successfully together with the cube library. So one has just extend the class path together with this value, and then it should work. Then we can take a look here. We can take a look at our shared directory. There are additional directories are created: doc, Java, and jCubeR. So in jCubeR we create a summary file where one can learn later on the options and settings which one has been using while building the library. In the Java directory we install the jar file, typical way, and in doc we provide documentation files and examples. We provide some rudimentary tool development guide where we demonstrate how one uses that library in Java code. As well, we demonstrate it in on example Java. We provide also example cube file and make file, so one can build it and see how one gets access to the data stored in this cube file. Okay, now we can proceed with another components. In this case it would be the CubeW writer. Very same step. I create build directory. I inspect command line options from configure script. Here already more options are available. The most interesting or most important options are these two, where a user can specify explicitly compile which has to be used to build the library. We support GNU, IBM, Intel, PGI, Studio, Clang, and OCC. OCC, I don't know. The default is set as a GNU compiler, so if one doesn't specify this command line options, the configure script will pick GNU compiler and use it for the build. The no-cross compiler or front-end compilers suits the options are used on the systems where the front-end and back-end are different. As well, one can enable or disable support of zlib compression. So if one enables it, the cube library, CubeW library, creates cube files which are compressed internally. One can specify if one builds shared library or only static. So by default both are created, and as well there are 3 additional features which one can enable. advanced memory features like usage of external memory allocator, tracing and tracking and tracing of the memory usage. These features are needed if one wants to fine-tune the memory usage of Cube library and keep track on it. By default, these features are disabled. So if we now do configure step in very same prefix like in with the Java Cube library, the configure script performs the tests and spits the summary in the end. It reports that it creates also CubeW config utility, and examples are located under this directory. We see that the back-end compression is enabled, but front-end not. And the advanced memory handling are all disabled. So the build system supports parallel builds. In my case, I have only 2 cores, so therefore I do Maj3, and I can also install as a next step immediately. So Cube the C writer library is a relatively small one, therefore the build step is actually really fast. We can inspect our bin directory, so we see that there is an additional tool, CubeW-config, which we can try to execute and see which command line options it provides. So here one can learn or get C-flags which one has to use to build some project using this C writer library. It reports LD flags, libs. So for example, LD flags, LD flags. Here, so it reports that one has to add this line into the compilation command so that the final project gets linked properly. As well, one can learn about version of CubeW which one has installed, about revision. If one would like to study its origin, in this case it reports it is external, one can inspect config, summary. Obviously one cannot, and interface version, it reports 11.04, so it is 11th version of API, 0's revision, and 4 interfaces back are supported by this version, by 4.7. Yeah, and if we inspect share directory, we see that we got additional CubeW directory where the summary of CubeW is stored. In doc directory we have as well CubeW additional, and there are also examples where one can learn how one uses API of C writer in C code with also corresponding makefile. So if we proceed then with CubeLib library, it is very same steps. So we create a build directory. So we also inspect command line, configure command line options. We see that because of auto tools, that they are very similar. As well with one can specify a compiler which has to be used to build a library. One can specify whether one wants to have shared library, static library, both of them. But additionally to it, one can specify some options which allow either fine-tuning or debugging of the library itself. For example, one can fine-tune the buffer size for I/O operations. One can specify so-called data loading strategy. Currently, the data is loaded on demand, so by first access, Cube library reads it from the file and then keeps it in memory. There is a preload strategy where the whole data gets read into the memory by first creation of Cube object and kept in memory. So in this way there is no I/O anymore after that. There is a manual strategy where every time you want to access the data you have to load it first, and there is a last n strategy where the only last n rows are kept in the memory, and this n is specified with another command line options with n rows. One can specify whether one uses system parser or not. That is for the case if one would like to regenerate our metadata parser. So we provided already generated one, but if one has modified the Y files or Lex files, one can regenerate it and using the own parsers. One can disable build of the tools if one doesn't want to have them. One can disable support of R library in CubeDump tool utility. It's not always the R develop package is not always available on a system, therefore one can disable it or enable it. Auto configure script tries to detect it automatically. So for the internal performance analysis, one can specify the score P, pass to score P, and one can use the score P itself to analyze the performance of the Cube library, and one can enable compression, level of compression from full to none. The default value is read only. So we, in this case, we don't specify any command line options. We install it in the very same prefix, and we are just happy with default values. So the configure is running, is performing tests, checking which standard C++ compiler provides, and in the end we provide the summary step, summary report, where we show where the CubeLib config tool is installed in the same way like CubeW config, where the examples are installed, we see that networking is enabled when POSIX sockets are used, internal cache is enabled, and we are building a library in the tools as well. Compression is in read-only mode. It means we can read compressed files, but we do not produce compressed files. And the support of R in CubeDump utility is also enabled because the development package is installed. The data load strategy is keep all in memory, load on demand, and here are command line options of the compiler. So as previously, build system supports parallel build, and therefore I can execute it, make with command line option -G. So we proceed with our video installation. The Cube library is finishing its build. The tools are being created and installed. So the Cube library has been successfully installed. We can inspect again the bin directory. We see that next to the config tools we have got also various command line tools which are provided together with command line with CubeLib library. These are CubeDiff, CubeDump, CubeInfo, CubeRemap, CubeServer tools. If one wants to name the most important tools, probably. As well, there is a Cube library, CubeLib config tool, which provides info to the user how one uses this library. So if one would like to build a project using which uses this Cube library, if we inspect the shared directory, we again see that doc library directory has been updated, and we provide user guides in form of PDFs or in form of HTML. In this case, for example, user guide about derived metrics, which one can learn how to use them, and so on. And we also provide a set of examples with a Cube file where one can learn how to use Cube API. The functionality of this command line tools one learns in another videos on this channel. Here we proceed with the last component with CubeGUI. CubeGUI. Create again build directory, inspect configure command line options. which are a little bit more than in case of lib or in W package. Here is most important probably is the command line options with Qt, where one can specify explicit path to the Qt QMake tool if it is not in one of these directories where we look automatically. One can also explicitly specify a specs file if it is not default, and also one can specify compiler suite, which is should be used to build a GUI. Here one has to keep in mind that the used compiler should match to the compiler which has been used to build Qt. Therefore, this range might be wider than actually possible compilers, because Qt supports only GNU, IBM, and Intel, as far as I know. One can enable as well debug. One can enable or disable shared and static build of static libraries. One can disable build of various plugins which we provide together with CubeGUI. By default, they are all enabled if requirements are met. Otherwise, the build system will disable them. One can also specify path to Scorpy if it is not automatically accessible via path. If one would like to do performance measurement of the GUI itself. We do very same installation in very same prefix, which would be 4.7, and if one doesn't specify anything further, the configure will stop because it doesn't know where the cube library is located. So in this case, cube library is CubeGUI has a hard dependency on cube library, and therefore one has to provide a path to CubeLib config, either via path variable or via explicit command line options. So we do the last one, CubeLib and the path. Our CubeLib is installed in very same directory like our prefix goes, so therefore it's sufficient if we specify it, and then we configure it again. So this case, this time the configures the script goes further and reports in the end the summary, where we can check that our CubeGUI config is installed in 4.7 in prefix. We get examples installed. We are using provided CubeLib with this flex. Our CubeDebug and warnings are disabled. We are using 5.15.3 version of QMake, that is the standard installation on my system. We see that the Qt web engine is enabled. The CubeGUI is using multithreading to calculate its values, and of course this range of plugins, all of them are disabled, so obviously all requirements are met, and the CubeGUI can demangle the names of regions in its while presenting them. So therefore we can proceed with the build. Again, we can do parallel build and we can install it. So the CubeGUI is finishing its build, as it's installing the plugins and the binaries into the prefix directory, and we can take a look what we've got. The final steps. And we are done. And again, when we inspect the bin directory, like here, we see that we get cube executable for the CubeGUI, and as well we get CubeGUI auto-completion shell script, which we can now manually source, so that we have then auto-completion functionality enabled. If one installs the software using some kind of automatic system, modules, or spec or similar, this sourcing of this script is usually enabled by default, and one gets auto-completion feature by default. As well, we get examples in corresponding directory, and we get also user guides as PDF or as a HTML file. So if we just inspect it shortly, for example, guide, we see that very same document which is published on our website, and here one can read about the GUI, about components, menu, and so on, or one can watch another videos which will be published in this channel. So in this video we installed all three components, and they are now available under specified prefix directory, and can be used for the performance analysis. How to use this or another tool we will explain in future videos. Thank you for listening. Please don't forget to comment, subscribe, and give us a like.